Okay, so we're going to do binomial probability today. And then again, it's this formula right in the middle of page 838, this one right here. So you're definitely going to want to write that down. Let me move my mouse. I'll go over on the side and write it down for you guys so you can see it a little better. So let's go over here. And then I'll define what all those letters mean. Let's see. Okay, so the formula was, it says P of R so P of R equals, and then it had a combination in front, and the subscripts were N and R, and then it had P to the, let's make sure one of these looks like an N. So that one's an N, this one's an R. And then it had P to the R power, and then it had Q to the N minus R power. Like that. And then we just need to define what all these things are. So the R is the number of successes. And then the N is the number of trials. And then the P, that is the probability of success. For one trial. And then the Q, that is the probability of failure. I could make it. So that's the probability of failure for one trial. All right, so that defines all the letters there. So keep all that in mind. So R is the number of successes, N is the number of trials, P is the probability of success for one trial, and Q is the probability of failure for one trial. You guys good with that? Everybody got it? All right, well, let's look at a problem then. So if we go over here, I think the one I want to do is actually down here at the bottom. Actually, I kind of want to make up my own first. So I want to use this example right here, this one. Okay, that's right on the bottom of page 838. And then, but I want to do a slightly different one, so let me write it out. We'll do this one first. So what we got here in the one I circled in blue, it says that Ellen is taking a multiple choice quiz. It only has 5 questions. And then there's 4 answer choices. So each multiple choice question has like answers A, B, C, and D to choose from. And then it says, what is the probability that she will get at least 2 answers correct by guessing? So she's just going to randomly guess on these 5 questions, and they want to know what's the probability that she's going to get at least 2 of them correct. But before we do that, I want to do a slightly a more basic problem than that first, okay? So we're going to write, what, let's see if I can slide this up a little more. Maybe I can move this with my, all right, so we're going to write what is the probability so what is the probability that Ellen guesses all right, let's see. Let me think about this for a second. I guess we'll do it this way. Guesses correctly on exactly 3 questions. Okay, so we're going to do that problem first. So we want to know what is the probability that Ellen guesses correctly on exactly 3 of the 5 questions. All right, so let's go over and we'll go over on this side and we'll rewrite that formula. So the formula we're going to use is the probability of R successes is equal to this combination where we've got N trials and R successes times the probability of success to the R power and times the probability of failure to the N minus R power. All right, then we're going to write down what all of these variables are. So R equals, okay, R was the number of successes. So how many times did I want her to be successful out of the 5 questions? Let's go back. That's what I just wrote down, right? I'm all messed up. Hold on. Well, you guys can read it right there. How many successes do I want out of the 5 questions? The one that I wrote, not the one that I circled in blue. How many? 3, yeah. We want her to be successful 3 times, right? She's going to guess correctly on 3 of the 5 questions. So that means R is going to equal 3. So we'll come over here. So R is going to equal 3. And then N is the number of trials. So how many trials is there? How many times is she guessing? Louder, please. 5, yeah, there's 5 trials, right? There's 5 questions. And then be aware that these events are, they're independent, right? Like when she does each trial, when she guesses on each question, that's totally independent of the previous question that she guessed on, right? So these are independent. So N is the number of trials, so it's 5. Because there's 5 questions. So she's guessing 5 times. And then we need the probability of success. That's P. All right, the probability of success, if there's answers A, B, C, and D, what's your probability of guessing correctly? What's that? 1/4. You guys all good with that? There's 4 possible answers on each question, right? A, B, C, and D. So your probability on each trial, or your probability for 1 question or for 1 trial, your probability of success is 1 out of 4. Because there's 4 answer choices, A, B, C, and D. And then Q is your probability of failure. So if you got a 1/4 chance of success, what's your probability of failure then?
3/4.
Good, 3/4. So if there's 4 answer choices, A, B, C, and D, your chances of guessing incorrectly are 3 out of 4. And then notice notice that these two answers right here, they always add up to 1, right? Because if you looked at your probability of success or your probability of failure, if you add those together, that's got to equal 1, right? That's got to happen 100% of the time. You're either gonna succeed or you're gonna fail. So you might want to make a note about that. These always add to 1. Okay. Now let's see if we can set this up. Why don't you guys, does everybody have a graphing calculator? I want to make sure you know how to type these in. If you didn't grab one real quick. So basically all we got to do is plug these numbers in for where they go for the variables there, and then just put it in the calculator and we're done. So here we go. So we're going to do the probability of 3 successes. So she's going to guess correctly on 3 of the 5 questions. That's going to equal this combination, the number of trials here. We're doing 5 trials with 3 successes. And then P is the probability of success is 1 out of 4 on each trial. And that is to the R power, which was the number of successes. And then times the probability of failure, which was 3/4. And that was to the N minus R power, which would be, well, if she guessed correctly 3 times, then she would guess incorrectly twice, right? So again, where I got this 2 right here from, that was the 5 minus the 3, okay? That was the N minus R. Okay, so we just put that in the calculator. Now, if you want to, you can do this separately. You guys know how to do that, right? Make sure you know how to do that for the quiz on Thursday. So you can do that combination on the calculator. If you don't know how to do it, get some help from somebody sitting by you. If you want to, you could enter this in as 0.25, and you could enter the 3/4 in as 0.75 if that's easier for you, but it doesn't matter. And or if you want, you can just enter the whole thing all at once, just like I wrote it. And it should kick out the answer, so let me do that. So I'll do it on my calculator. So I put in the 5, then I go to math. Then I go across the top of the screen to probability. I choose number 3, which was the combination. Then I put in the other subscript of 3. And then I put in 1/4. So I'll put a parenthesis, 1 divided by 4, parenthesis. Then I raise that to the 3rd power. And then that'll be times, in parentheses, 3 divided by 4. And then that will be to the 2nd power. And that should give me the answer. What'd you guys get? Anybody got an answer for me? I got it as a decimal. What'd you get? 0.087. Perfect. Yeah, you get 0.08. Well, actually, if you round off to the 3rd digit after the decimal point, it would be 0.088. So you should get 0.088. And then if you want to change that from a decimal to a percent, just move the decimal point 2 places to the right. So that is 8.8%. So this kind of blew me away that these guys figured this out way back when, all right? They came up with that formula, and again, I'm going to show you how that's related to yesterday's lesson, probably tomorrow. But still, they actually figured this out. Like literally in this class, if I gave you guys 5 multiple choice questions with 4 answer choices, A, B, C, and D, and I wanted to say, well, what's the probability that you're going to guess correctly exactly 3 times out of the 5 questions? You would do that about 9% of the time. You would get 3 out of 5 correct. Sounds right. It's not, you're not going to be able to get 3 out of 5 just randomly guessing that often. So you're only going to get that 9% of the time. Now, of course, some people in the room are only going to guess 1 correct, right? Or 2 correct, or maybe 0 correct. And some people will guess all 5 correct. But if you average that all together, it's going to get closer to 8.8% of the time. Now with this small of a sample, with 25 people in the room, it might be off a significant amount from 8.8%. But if we get the whole school to do it, the whole school guesses on 5 questions that have 4 answer choices. The more people we do it, when we average them all together, it's going to come out to be that 8.8% of the time they got 3 out of the 5 correct. Okay. Well, let's answer the second part of the question now. Or actually, it was the first part. It was the part that I circled in blue. So let's go back and look at that. And that's really going to be my only other example for today. This is a little bit more tricky. So the other part of the question we wanted to do was this blue part. How come, what's going on here? I'm stuck. There we go. This part. So the key word on this part is where it says at least 2 answers correctly, all right? So same quiz. It's got 5 multiple choice questions. It's got 4 answer choices, A, B, C, and D. But this time we want to know what's the probability that she gets at least 2 answers correct. So that's the part you need to be aware of. This one said exactly 3, right? This one says at least 2. Well, if she's going to get at least 2 answers correct, then she could get 2 correct, or she could get 3 correct, or she could get 4 correct, or she could get all 5 correct, right? That's what at least 2 means. Now, the rest of the setup here is going to be the same, okay? This is still going to be the same. There's still going to be 5 trials, right? 5 questions. The probability of success on each trial or each question is going to be 1/4. The probability of failure on each question is going to be 3 out of 4. So that part doesn't change, okay? But here's the part I want to write out for you. Let's see if I can slide over here again. I'm all the way down already, aren't I? Yeah, I am. Okay. Maybe I got room on the other side for this one? Yeah, let's do this one over here. All right. So let me think about these probabilities for a second. Well, there's the probability that you get 0 correct, right? Or the probability that you get, well, notice I said the word or. What do you do with probabilities when you see the word or? If you have the word and, you would multiply the probabilities, right? But I just said you could have the probability of 0 correct or the probability of 1 correct. So what do you do with the word or? What do you do?
Divide.
No, it's not divide. Think back to the last quiz. When it had the word or in there, what did you do with the probabilities? If it had the word and, you multiplied. What do you do with the word or? Oh, I heard it out there. Who said it? Yeah, you add. So we have the probability of 0 correct, or the probability of 1 correct, or the probability of 2 correct, or the probability of 3 correct, or the probability of 4 correct, or the probability of guessing all 5 correctly. Well, one of those 6 things has to occur, right? If one of you guys tried it, I gave you the 5-question quiz with the answer choices A, B, C, D. One of those 6 things right here has to come true, right? You're either going to get 0 correct, or 1 correct, or 2 correct, or 3 correct, or 4 correct, or you're going to get all 5 correct. One of those 6 things has to happen 100% of the time, right? That means that these all have to add up to 1. They would add up to 100%, but 100% as a decimal is just 1. All right, so one of those things has to occur. That's why the probability of all of them added together is 1. Now, we want the probability of at least 2 correct. So what we want is we want this part right here. We want this, right? That's the probability of at least 2 correct. I could get 2 correct, or 3 correct, or 4 correct, or 5 correct, right? So that part is what we want. We want at least 2 correct. Well, we already did this one, right? That was the previous problem I did. I did the probability of getting 3 correct. Hold on one second, guys.
Thank you.
Carter, you got to go. You got to come grab this pass for me. Does that make sense to you guys? We just did this one on the last problem, right? That was the probability of getting exactly 3 correct. Well, guess what? To get this answer, we got to do 4 of these things. And we got to add them all together to get the answer. That doesn't sound like very much fun, does it? So what I'm going to give you as another option instead, since we want this blue part here, where at least, I should have put at least 2 correct. I forgot to do that. Let me put that in there. That should say at least 2 correct. So fix that on your notes. All right, so we want this. We want at least 2 correct. So instead of finding all 4 of those probabilities and adding them together, what I'm going to do instead is I am going to subtract off on both sides. I'm going to subtract off the probability of getting 0 correct or 1 correct. So over here, I'm going to subtract off the probability of getting 0 correct plus the probability of getting 1 correct. And on the other side of my equation over here, I'm also going to subtract that. So over here, I'm going to subtract off the probability of getting 0 correct or the probability of getting 1 correct. Hopefully you can read that over there. And then these guys are going to cancel out over here. So that means if I want the probability of getting at least 2 correct, what I can do instead is I can do, if you read this right-hand side over here with me, this part, this blue part of at least 2 correct is equal to 1 minus the probability of getting 0 correct or 1 correct. So let me write that down. So we're going to do this instead by going, we need 1 minus the probability of the 0 correct or 1 correct. That's going to give us our answer. So that's a little bit easier. So now instead of having to do 4 of these things and add them together, now I only got to do 2 of these things and add them together and then subtract that result from 1. So that'll save me a little bit of work. Now you might say to me, well, that's not that bad. I'm just going to do these 4 and add them together, which is fine. You can do that if you want. But if I had 20 questions instead, then I'd have the probability of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Which means if I wanted to do it by, if I said, what's the probability of getting at least 2 correct out of 20 questions, then this part that I added together right here would have 19 probabilities to add together. And I don't think you want to add 19 probabilities together. So you're definitely going to want to use this idea where you subtract the probability of 0 correct or 1 correct. In fact, what we're really using there, guys, is we're using that complement idea, remember? So what we're really doing is we're taking this right here, this probability of 0 correct or 1 correct. Well, that's really the probability of not at least 2, right? The probability of 0 correct or 1 correct is really not at least 2 correct. So I'm going to find that answer and then just subtract it off 1. So let's do it. Let's set it up. So here you go. So we're going to go, and then we're going to be done. So we're going to go 1 minus, parenthesis. Now remember, this number here, that's your R, right? That's your number of successes. Now the rest of this thing stays the same as what we had before, right? Where were we? We were over here, right? So the R changes, okay? we're going to change this. But the n is still 5. There's still 5 questions. The probability of success on each question is still 1/4. And the probability of failure on each question or each trial is still 3/4. So none of that changes. So let's see if we can do this. All right, so here we go. So this one is going to look like, well, you got that combination out in front, right? And you still got 5 trials because you got 5 questions. Your number of successes here is 0. You're guessing 0 correctly. And then that's times the probability of success, which was 1/4. And the power on that is the number of successes. And then the probability of failure, well, that was 3/4. And the exponent on that was n minus r, right? So that's actually going to be the number of failures. So if you got zero successes right here, if you do 5 minus 0, that means you've got 5 failures, right? And then to that, we got to add on the probability of 1 success. Well, again, you got the combination out in front. You still got 5 trials or 5 questions. Now you want 1 success, so you want to guess correctly once out of the 5 questions. The probability of success is still 1/4 on each question. Now that is going to be to the number of successes power, which is 1. And then you got the number of, or you got the probability of failure. And that exponent is going to be 5 minus 1. Because if you've got 1 success on 5 questions, you guessed correctly once out of the 5 questions, that means there's going to be 4 times that you fail, right? Let me fix that so that it actually looks like a 5. There. All right? And now you just got to stick that whole thing in your calculator and it'll give you the answer. Again, you have the option of you could, find this number first. You could make this 0.25 and that 0.75. It's up to you. You could do it in decimal form or in fraction form. But somehow you got to put that whole thing in the calculator. Now, if you want to, you can type the whole thing just like I wrote it. All right, so let me do it. And then I'll ask somebody and see what you guys got. All right, so let me take a second to do this. Hold on. So I got 5. And 0, and we'll go 0.25. Now, 1/4 to the 0 power, what's that? What's any number to the 0 power?
1.
So that 1/4 to the 0 is just 1. But it doesn't matter. You can still put it in there as 1/4 to the 0 power. I just messed mine up. I think. Oh, I see it. What did I do to this thing? Well, you guys are going to get done quicker than me because I just messed up typing mine in. I still messed it up. All right, I got to redo mine. I screwed it up. Let me see if I can go faster this time. I tried to shortcut it when I put it in and I messed it up. right, better work this time. There we go. Okay, what'd you guys get? Anybody got it? Sorry it took me so long, but I tried to put it in there in decimal form, and I wasn't using the parentheses around the 1/4 and the 3/4, and it gave me an error. So I had to go back and put the parentheses in. I need an answer. 1.16? No. Sorry, that's not it. So I added those two together first, then I subtracted them off the 1. Yeah. Say it again? No, that's not it either. Anybody else got another answer? You're going to have to do this on the test on Thursday, or the quiz. Say it again? There you go. Yep, it's 0.367. Thank you. So you should have got 0.367. Which if you move that decimal point 2 places to the right, that is 36.7%. Okay, so if I had a 5-question quiz with 4 answer choices, A, B, C, and D, and then I had you guys guess just randomly at the 5 answers, you would have about a 37% chance of getting at least 2 correct. You could get 2 correct, or 3 correct, or 4 correct, or all 5 correct. But you would get one of those, either 2, 3, 4, or 5 correct. That would happen 37% of the time. All right, now is it possible that you might get 0 correct or 1 correct? Yeah. But if you take everybody in the room and we look at the average results, it's going to happen 37% of the time. Now, with this small sample, again, it might not be perfect, but if we did it with the whole school, we would find that it would get really close to 37% of the time people got either 2 or 3 or 4 or 5 correct. And that's it. That's today's lesson. So again, tomorrow I'm going to give you guys like a homework ticket on this topic right here. And then I'm also going to show you how this is related back to Pascal's triangle. And then I'll put out the practice quiz for you guys. All right? So let me stop recording this. I guess maybe I could, I'll put the assignment up on Schoology. I won't write it up on here.